All right, I want to solve this by graphing, so I'm going to graph these two equations, and then we're going to check our solution by solving it using substitution, which we learned on Friday, or we talked about on Friday. For this top equation, how do I graph that one? Yes, we have to start at positive 4. Here's my y-intercept at 0, 4. So right here, and then you said I go from there I go where, Michael?
You go down 2 and to the right.
Yes. Our slope is -2. We turn it into a fraction by putting it over 1. So this is going to be down 2 and to the right 1. So down 2, right 1, down 2, right 1, until I can't go any further. One thing I want to make sure to point out, I haven't seen it happen so far this year, but every year it does end up happening at some point. If I ask you to graph a line for me and you leave it like this, that will not receive full points. Yes, sir? Yes, you may. If you leave it like this, it would not get full points. Why not? Why would I not give full points for this? It's not a line. These are the points that are on this line. To get full points for graphing a line, you actually have to connect those dots. All right, so there's one of our lines. If I wanted to graph this bottom line, what do I need to do? What'd you say? I still can't hear you. I apologize. Put a dot on -3. Yes. Tell me how you got that. We're going to change it into slope-intercept form. So I want this to be in y equals mx plus b form. So I would start by adding x to both sides. So I would have 3y equals not -9x, but x minus 9. And then you divide each piece by 3. Next to that x, there is an invisible 1. This is a 1x divided by 3. So that would be 1 over 3x minus 3. This is the line that we're going to graph. So here is our y-intercept at 0, -3. Right down here. And then what is our slope? Slope is not negative. This piece right here is my slope. It's 1 over 3. The 1 is my rise. It's positive, so I'm going to go up 3. Or sorry, not up 3, up 1. And then this is my run. It is positive, so we're going to go right 3. Yes. Because we added x to both sides. So we have a positive x and a -9, and then we divided by 3. So I have a positive 1 divided by a positive 3 for my slope. You got it? Okay. So from that blue point on the -3, I'm going to go up 1 and right 3, up 1 and right 3, up 1 and right 3. I'm going to go backwards as well, so down and left. And then I would grab my straight edge to go through those points. What am I looking for when I solve by graphing? I'm looking for my solution. How do I know where that solution is? Where they cross each other. So right here is our solution. What is that ordered pair? 3, -2. All right, so our solution is 3, -2. Let's check that using solving by substitution. That's what we learned on Friday. When we solve using substitution, I need one of my equations solved for a variable. I'm going to go back and look at these original equations. y equals negative 2x plus 4, negative x plus 3y equals negative 9. This top equation is solved for y. So down in the bottom equation, we're going to call y off the field. We're going to sub in all of this. So I would have negative x plus 3, and then in place of the letter y, I would have negative 2x plus 4 equals negative 9. What would I do to it next? We're going to solve, so what do I do as I'm solving? What's my next step? Yep, we're going to distribute that 3. And if you said that already, I apologize, I couldn't hear. So I have negative x minus 6x plus 12 equals negative 9. Are there any like terms that I could put together? What can I combine? The x's. Negative 1x and negative 6x combine to give me what? Negative 7x plus 12 equals negative 9. From here, I'm going to subtract 12 from both sides. Be careful. What is negative 9 minus 12? Negative 21. And then what would I still need to do to get the x all by itself? Divide both sides by negative 7. What is negative 21 divided by negative 7?
3.
X is positive 3. What did we say the x part of our ordered pair was? 3. So we got the same thing. I want to substitute that answer back into one of my two original equations. I picked the top equation because it looks easier to me to find y. So y equals, this would be negative 6 plus 4. What is negative 6 plus 4? Negative 2. That's what we got for the y part of our ordered pair. So we can solve using more than one method. We should get the same answer either way. Solving by graphing, solving by substitution. Today we're going to talk about the third and final solving method. This is solving using elimination. Solving using elimination. Grab your books for me. We're going to be on page 109. Yes, ma'am. All right. Couple things I want to change up at the top of page 109. We have 3 steps for the elimination method, just like we did for the substitution method. Step 1, we want to multiply one or both of the equations by a number to result in 2 equations that contain opposite terms. I want you to cross out where it says or equal. Opposite terms. So when I say opposite terms, what I mean is something like 5x and negative 5x. Or negative 12y and a positive 12y. Because if I add opposites together, what happens? They cancel. That will eliminate that one variable. When it says we will eliminate the variable, it will cancel. Once we make a variable cancel out, we're only going to have one variable left, just x or just y, and then we will solve for that remaining variable. We're going to take the answer, plug it into one of our 2 original equations to find the other piece of our solution. All right, let's go look at example number 4. Looking at these two equations, does anything stand out to you? What'd you say?
I don't know if it's right, but 9y.
9y and 9y. We have negative 9y and negative 9y. If I add those together, negative 9 plus negative 9, what does that give me? Negative 18. That doesn't cancel. I need one to be a positive and the other to be a negative. Does anybody remember what we've done in the past when we want to change the sign? Yes, ma'am. Yep, we can multiply one of these equations. What would we multiply by if I want to change just the sign but not the number? If I multiply by a positive, my number will change but not my sign. What do I multiply by if I want to change the sign but not the number? If instead of a negative 4, I want it to be a positive 4. Instead of a negative 9, I want it to be a positive 9.
Oh, you multiply by the opposite.
Negative 9.
Not by negative 9.
Wait, if you...
Negative 1. If I multiply by negative 1, hold on just 1 second, and then I'll take your question. If I multiply by negative 1, that'll give me a positive 4x instead of a negative 4x. If I multiply by negative 1 here, I'm going to get a positive 9y instead of a negative 9y. Multiply by negative 1. If I do it to one piece of my equation, I have to do it to all the pieces of that equation. What was your question, sir?
Is this the thing where we got to put the little bracket on the side and multiply them?
Mm-hmm.
I know, yeah.
Yep.
We did that last year.
Yes. When I write it down, I'm distributing it already, but yes, that's exactly what we're doing. Negative 1 times negative 4x gives me a positive 4x. Negative 1 times negative 9y gives me a positive 9y. What is negative 1 times negative 23? Negative 1 times negative 23.
Are we looking for 0 here?
Positive 23. We are looking for when I add these two equations together, one of them will cancel.
Oh, so not 0 here.
Not necessarily. I'm not super familiar with that phrase. Maybe you can explain it to me later. All right, I'm going to recopy that top equation. We didn't do anything to the top equation. So negative 2x minus 9y equals negative 25. Now I'm going to add these two equations together. Are these two like terms? 4x and negative 2x. Are those like terms? Can I combine them? Yes. How do I know whether or not they're like terms? They have to have the same variable. X and x, I can put them together. What is 4x minus 2x? 2x. Are my y's like terms?
Yeah. No.
What happens when I add those together?
She cancels.
They cancel out. They give me a 0. Not a 0y, just 0.
Almost, but that's what we just did. It's basically
Okay.
where you got to find the equation that cancel each other out to get 0.
Yep.
And negative 2.
And negative 2. So this 0 right here, I just ignore that. 2x equals negative 2. Divide both sides by 2, and you're right, we do get negative 1. So x is equal to negative 1. Am I finished? We got to substitute back into one of these two original equations. Do you guys want to use the top one or the bottom one? It doesn't make any difference, but we have to pick one.
Top one.
Top one, okay. So my top equation was negative 2x minus 9y equals negative 25. And what am I putting in the place of x?
So if we use the bottom one, are we going to use the one that we added, multiplied?
We'd always go back to the original. Always back to the original. Great question. Whenever we substitute in, we want to go back to the equation that we did not manipulate at all. I'm going to put negative 1 in the place of the x. What is negative 2 times negative 1? Positive 2. So I have 2 minus 9y equals negative 25. What's my next step if I'm trying to get y all by itself now? Minus 2 from both sides. What is negative 25 minus 2? Negative 27. Where to now? Divide both sides by negative 9. We get a positive 3. So y is equal to positive 3. What is my solution then? Negative 1, 3. My solution when I have two linear equations is going to be the ordered pair with the x part first and then the y part. Awesome. What questions do you guys have about this one before we go look at another example? Any questions? All right. Top of the next page for us. Example number 5. Last time we saw that there was a negative 9y and another negative 9y. Do I have anything like that this time? No. We'll look at these first two right here. Is there anything that you would multiply 2 by to get 3? Anything you would multiply 3 by to get 2? Okay, so that's not a good choice. Would you multiply 5 by anything to get 4?
No.
4 by anything to get 5? If that's the case, we need to decide which variable we plan on eliminating. There's not a best choice here. It does not matter which one you pick. Do you guys want to eliminate the x or eliminate the y? Sounds good. We have decided to eliminate x. So that's where I'm going to be looking. We're going to look right here at these two. What do I want to be true about the numbers in front of the x's? I want to make these things cancel, so what has to be true about the numbers in front?
One has to be positive, one has to be negative.
One has to be positive, one has to be negative. But I have like a positive 5 and a negative 4, and you guys didn't like that pair.
No. Oh, it has to
It has to cancel each other.
Has to cancel each other. So it needs to be the same number, just one positive and one negative, like positive 5 and negative 5, or positive 3 and negative 3. Do 2 and 3 have anything in common?
Yeah, they both have x's.
They both have the x's, but I'm talking about just the numbers themselves.
Oh, no.
No. Then I'm going to multiply the top equation by 3. I'm going to multiply every single piece of my top equation by 3. If I multiply the bottom equation by 2, will they cancel?
Yeah, yes, the 2 and the 3 gonna cancel. Because they both gonna be 5.
I'm going to get, not if I multiply, honey.
Oh, 6, I mean.
I'm going to get 6 and 6. If
Yeah.
you add 6 and 6, will they cancel?
Oh, no. One has to be a negative.
Which one do you want to make negative?
The bottom one.
Sounds good. So I'm going to multiply by negative 2 all the way across. So up on the top, when I multiply everybody by 3, I'm going to get 6x plus 15y equals 3. What do I get when I multiply everybody in the bottom by negative 2?
Negative 6.
Negative 6x.
Negative 8y.
Negative or positive?
I mean,
Positive 8y. And a positive 20 back here. We're going to add these two equations together now. What happens with my x's?
They cancel.
They cancel out. What do I get when I add the y's together?
23.
Yep, I get 23y equals what? 23. So 23y equals 23. What is y? 1. I divide them both by 23. And y equals 1. What do I still need to do?
You gotta get x.
I need x now. How do I find x now? Substitute in. Does it matter which equation we choose?
No.
Which one do you guys want to use today?
The top one.
Top one sounds good. I'm going to go all the way back to our original. So 2x plus 5y equals 1. We are substituting in the place of the y. So I have 2x plus 5 equals 1. What do I do next? Minus 5 from both sides. What is 1 minus 5? So 2x equals negative 4. Divide both sides by 2. X is negative 2. So what is my solution? Yes. My solution is negative 2, 1. Questions so far? All right, we're going to look at one more example, but we're also going to do a little bit of writing in the margin on this next example. So we're on example number 6. Is there a better choice here, a best choice, whether we eliminate the x's or eliminate the y's? Not really. So we need to decide which one we plan to eliminate, right? Which one do you guys want to eliminate? Sounds good. Let's do y. We have decided to eliminate y. So I'm going to come over here. I'm going to look at these y's. Do 21 and 7 have anything in common?
Yes.
Yes. Do I multiply 21 by something to get 7?
No, you multiply 7 by something to get 21.
7 times 3. If I multiply 7 times 3, I'll get 21 and 21. Will they cancel?
No, they gotta be negative 3.
Negative 3. So let's multiply everybody down here by negative 3. All right, so that gives me negative 18x minus 21y equals negative 6. I'm going to recopy this top equation down here. Positive 18x plus 21y equals 14.
Well, it don't make a difference what you put on top or the bottom.
Correct. It does not matter which one goes on top. Michael, you said what happens here? X cancels. That gives me a 0. Y cancels. That gives me a 0. What's 0 plus 0? 0. Does the other side cancel? It's 8. Is this true? No, that is not equal. This is not true. So what does that mean? No solution. All right. I want you guys to add this problem in the margin. You guys have some room to write in the margin over there. We're going to do almost the exact same problem we did here, but I'm going to change one number. So we're still going to have 18x plus 21y equals 14. For the other equation, we're going to have 6x plus 7y equals 14 thirds. I changed just one number because I want to see what happens with just that one little change. Can I approach this the same way I approached the previous problem where I multiply everybody by negative 3? Yep. Let's multiply everybody in the bottom equation by negative 3. So I would have negative 18x minus 21y equals, now I need your help with the calculator here, 14 divided by 3 times negative 3. Grab your cell phone calculators for me. 14 divided by 3 times negative 3. How much? Super close. Remember, we multiplied by negative 3.
Oh,
Negative 14. I'm going to recopy that top equation. 18x plus 21y equals 14. What happens now when I add them together? Everything cancels. I have 0 here, I have 0 here, and on the other side, I have 0. Does 0 actually equal 0? Yeah, that is true. So does that mean no solution?
It is a solution.
Hold on just a second. When my x's and my y's canceled and I got something that was false, we said no solution. This is what a solution looks like. So what happens when my x's cancel, my y's cancel, and I end up with something that's true? What would that mean? Infinitely many solutions, yes. Infinitely many solutions. Your book didn't have an example of one like this, so I decided to put one in because we need to know what this means. If that happens but it's not true, it's no solution. If this happens and it is true, then we have infinitely many solutions. If we can find an x and find a y, that is my one solution situation. All right. Do you guys have any questions for me about what we went over today? All right, that is the end of our lesson. You guys have the remainder of class time to finish up the homework that is due tomorrow. You've got pretty much an hour to get that done. 45 minutes is closer, actually. No, it's 5 minutes shy of an hour.